Kia ora koutou. Welcome everybody. So we've got our final lecture for this week for Math 101. Before we get stuck back into some maths, which I know you're all really excited for, I do just want to take one moment. I will have sent out an email to your UC Live inbox, which contains the consent form for the research project that I talked about briefly on Tuesday. I have Elliot here, who is here to help me collect those consent forms from you. If you could fill out that form now in your email inbox, that would be really fantastic. It is optional. If you don't do it, that has no impact on grades or your university or anything. So it's entirely optional. There is the online version, or Elliot has some paper versions, and we'll wander around with those. There's also the information sheet available on Learn or on the paper version that Elliot has. So they will be collecting the paper forms, so they don't come to me, so I don't know if you've agreed or not. That all goes through Elliot instead of me. So I will just let you guys get on with that for a minute.
So these are the lab workshops, correct? Three questions?
So to get the attendance grade for the lab.
Yeah, I emailed you about that. You
Yep.
said to do it online.
Yep.
Because I don't think there's enough room in the...
We can find you space if you want to go in person, but it looks like you've made progress. Yeah. So just submit the working for those ones.
Yeah.
To
I
get
just
that
wrote
grade.
those down. And then
Yeah.
are the first section of like the cap quizzes due tomorrow?
No, they're kind of due at the end of semester.
Okay. Oh, I just...
But if you can get through them, that's really useful to do.
Oh, sweet. Thank you.
Yeah, cool. How are we going? Cool. Yeah, that's what I thought. Shall I get started and you can wander around? I think there's a couple to collect already.
Okay.
But I think I might get on with it. It should be okay if you're just walking around. Yeah, that's okay. And then I'll give you that folder. Just put everything in there at the end. Yeah. Thanks, folks. So if you missed the start, you will have an optional survey that's been delivered to your inbox. If you could fill that out, that would be really useful, but it is optional. Elliot's going to come around and collect paper forms, and I'm going to get started with some maths. So we did that yesterday. Right. What we are working on today is solving some problems where we've got square root signs in the equation. We looked at briefly reminding ourselves what that square root sign means. Yesterday we mentioned briefly that the square root sign of a number, say 9, is asking us, well, I want some number there so that when I square that number, I get 9. So I want something in here so that that number squared equals 9. And of course, that could be 3 or negative 3. So square root of 9. The positive square root of 9 is 3. So that's reminding you what that symbol means. And so if I have something like square root of x equals 2, and I want to know what x is, then my main tool that I've got is to square both sides. So I'm going to work through an example and then take a step back to think about what's going on and some things we need to be aware of for those examples. So to start with, I'm looking at this example, and it says to me that the square root of 2x plus 1 is equal to x minus 1. So all this says is we can forget briefly for a moment about x's and all the numbers and things that are going on here. And what this says is that the square root of some number is equal to some other number. So I've got two different numbers here. The square root of this blue number is equal to the green number. And we want to rearrange this to get the information in a different format. Eventually, we want to find a number x that will make this equation true. But to start with, the first thing I want to do is get rid of that square root sign. Write an equivalent equation that does not have a square root sign in it. And so if I have the square root of some number a is equal to b, some other number, I can write an equivalent expression that says, well, I could square that, and then that new equation will be true as well. And then if I take the square root and then square it, that just gives me the number underneath back again. And I end up with a equals b squared. So that's the process, the tool I can use to get an equivalent equation without a square root. So I'm going to take this equation and square both sides. So if I square the left-hand side, I end up with the square cancels out the square root. So I end up with 2x plus 1 on the left. And that's equal to x plus 1, x minus 1, all squared. So what I've done is square both sides. And now what I've got is a quadratic equation that we can work towards solving. Because remember, our quadratic equations can come in this factored form. So if I want to solve this, I need to get it in my standard form for quadratic equations that we were looking at yesterday and the day before. So I need to expand this right-hand side. So x minus 1 squared means x minus 1 multiplied by itself. And then if I've got this factored form, I can expand it using our expansion and factorization skills. Did that cut out? Can you guys hear me? No, thank you. No, is it back? Right. I guess we hope it doesn't happen again. We can expand this using our expansion and factorization skills from the CAP Quiz 3 that says multiply the first two things together to get x squared, multiply the outside things together to get minus x, multiply the inside two terms to get minus x again, and multiply the last two terms to get negative 1 times negative 1 is positive 1. So I have 2x plus 1 equals x squared, take 2x plus 1. So we can see now that that's a quadratic, which we know how to solve. But if I want to solve it using my quadratic equation skills, I need it in standard format. So I need to make sure I've got a 0 on one side. So I'm going to subtract 1 from both sides. 2x plus 1 minus 1 equals x squared minus 2x plus 1 minus 1. And those plus 1 minus 1 will cancel out, plus 1 minus 1 will cancel out. So I get 2x equals x squared take 2x. And then I still want a 0 on the left, so I need to subtract 2x from both sides. And I end up with 0 equals x squared take 4x. And we can solve this either by factorizing or by using the quadratic equation. So I can notice that this is x times x minus 4 if I factorize. So I've got 0 equals x times x minus 4. So that means that x equals 0 or x equals 4. So we've got two possible solutions. And then as I've started talking about good practice for mathematics is to check your answer. And it's going to work out that when we've got equations involving square roots, it's going to be especially important to check your answer because sometimes we get a potential solution that doesn't actually work. So we want to check x equals 0. What happens if I put x equals 0 into my original equation? Well, the left-hand side was the square root of 2x plus 1, which is 2 times 0 is 0, plus 1 is 1, which is equal to 1. So the left-hand side is 1, and the right-hand side is x minus 1, which is negative 1. So these are not equal. That means x equals 0 is not a solution. What about checking x equals 4? Well, my left-hand side says the square root of 2 times 4 plus 1. 2 times 4 plus 1 is 9, so we're taking the square root of 9, which is 3. And the right-hand side is x, so 4 minus 1, which is 3. So these are in fact equal. So our solution is x equals 4. And that's our only solution here. And we've checked that if I put x equals 4 into my original equation, I do get a true equation. So we found a value for x that makes that equation true. So we wanted to find a value for x that makes this equation true, which we did do. So to take a brief step back, there's kind of a little bit of information here about what we were doing and what we need to watch out for. So the first thing to pay attention to here is what was our main tool that we introduced. The main tool was that we took the square of both sides. So we were taking the square of both sides of an equation. So my little example here says that what if I know that if 3 is equal to x plus 1, what is 9 equal to? Well, we took our statement 3 equals x plus 1, and 9 is 3 squared. So 9 is equal to 3 squared. But if 3 is equal to x plus 1, then that's equal to, then 3 squared is x plus 1 all squared. So what we've done here is we've taken our equation, 3 equals x plus 1, and we put brackets around everything on the left and said, let's square that. We've put brackets around everything on the right and said, let's square that. And what we've done is created a new equation so we can create a new equivalent equation by squaring both sides. Of the equation. And that was the step that we did right back at the start of this first problem. I took both sides of that equation and raised them both to the power of 2. I squared both sides. The other note I've got here in your notes is that in the green box, we always want to check if our solution is valid. Because remember, we got to the end of our last example and I had 2 possible solutions. I said x is 0 or 4. But when I put x equals 0 back into my original equation, it didn't actually work out. It wasn't a true statement. So when we've got square roots in our equation that we're solving, then we want to check, we need to check at the end. It's a good idea to always check at the end, especially when you've got the systems of linear equations. We practice double checking your answer at the end. When we were solving quadratic equations, we practiced double checking the answer at the end. And that's especially important as you're building up your foundational algebra skills, because that's where you'll catch out things like dropping negative numbers and so on. Okay. So I've got a few more examples to work through. And then we'll have a little bit more of a think about some more algebra that we can look at. I want to first do a new example. Cool. So I want to first do another example, maybe to slow it down a little bit. So suppose I want to solve an equation square root of x equals 7. So I'm asking, I've got a number x, and I want to know what that x is, when the information I have about x is that if I take the square root, I end up with 7. And so what the tool that we've introduced is to say, well, we can square both sides of that equation. I can take my equation, square root of x equals 7. I can put brackets around the left and square it, brackets around the right and square it. And if I have a square of a square root, that just gives me whatever's underneath, that x. So on the left, that becomes x. And on the right, that becomes 7 squared, which is 7 times 7 is 49. So x equals 49. And I could check that if I take the square root of x, I get 7, which is what I was aiming for. But to break this down even further, to think about why can we square both sides? So sure, that's a tool we can use, but we want to think about why we can do that. If we think back to when we first, on Monday's lecture, we started thinking about solving equations like 3x plus 1 equals 5. And we thought about this is two different numbers that are equal. 3x plus 1 is a number, and that's equal to 5. And we could think about putting those two numbers on a scale. I've got something of weight 5 over here, and something over here of weight 3x plus 1. So maybe I can think about this as weights. I don't know what x weighs, but I've got 3 of them on the left plus an extra 1, and I've got a weight of 5 on the right, and they're equal. If I want to maintain that equality, I can add the same thing to both sides. So maybe I add a weight of 2 to both sides. Add a weight of 2 over here, add a weight of 2 over here. I'm still going to maintain that equality. So that's like doing a plus 2. So that would tell me 3x plus 3 equals 7. If I had a true statement before, I still have a true statement now. I've done the same thing to both sides. Or we could multiply by the same number. I could say whatever I've got on the left, 3x plus 1, I know that's equal to 5. So I know if I multiply the left by, if I multiply 3x plus 1 by, we could multiply by 3, and I multiply the right by 3, then that's still true. If I've got two equal numbers and I triple both of them, they're still equal numbers. That's all I've done. So why am I talking about this when we want to think about squaring? So my original example was I want to solve square root of x equals 7. What happens if I multiply both sides by 7? If it was true before, if square root of x equals 7 was true, then multiplying both of those numbers by 7 still maintains a true statement. But let's think about this 7 on the left. What else do I know about 7? I know that 7 is equal to the square root of x. So I could actually write that as the square root of x times the square root of x equals 7 times 7. Because this step has happened because we know square root of x equals 7. And so what I've done at this point is I've got, well, if square root of x is 7, then the square root of x times by itself is equal to 7 times by itself. And a shorthand way of writing that is 7 squared on the right and square root of x squared on the left. So that's all I'm doing when I'm squaring both sides, really, is I'm multiplying both sides by that same number. And so then a next example we could think about is, what if we have a little bit more work to do than just that squaring step? So I could have square root of x minus 1 equals 3. It's a little bit harder again, but again I could say, well, I want to solve this. So I want to multiply, let's multiply both sides by 3. We can go 3 times square root of x minus 1 is going to be equal to 3 times 3. So we've multiplied everything by 3. It's still going to be a true statement. On the right-hand side, 3 times 3 is just 9. On the left-hand side, I could keep that as 3 times the square root of x minus 1, but that's not really going to help me. I want to actually remind myself that this 3 I can write as the square root of x minus 1 because I know those two numbers are equal. So I've got the square root of x minus 1 times by itself. So that's just x minus 1 square root all squared equals 9. But because the way I've defined the square root, if I take the square root and then square, I just end up with what's underneath. So x minus 1 is equal to 9. So if x minus 1 is equal to 9, I can add 1 to both sides, and I get x equals 9 plus 1 is 10. So that's my solution. And then, of course, we want to check what happens if I take the square root of 10 minus 1. Well, that's the square root of 9, which is 3, and that's what I was hoping for. So that's some more straightforward examples, but also trying to motivate why it is that we can just square both sides. So when I'm saying square both sides, it's really a shortcut for saying I want to multiply both sides by, in this example, 3. Except I want to express 3 in different ways. I can use the fact that 3 is equal to the square root of x minus 1. So I can interchange it. Any questions at this point? I've got some more examples to work through as well. Okay, I will move to my next example. So example 4.4 in the notes. Again, I'm looking at this and I've got square roots. I want to solve this, and so I'm going to have to get rid of those square roots somehow, which means I'm going to need to use our tool of squaring both sides. So just to recap I know that square root of x plus 5 is equal to the square root of 2x plus 1. So I'm going to multiply both of those, multiply the whole equation by some number. And the number I pick is going to be the square root of x plus 5. Except on the right-hand side, that's not going to be very useful to be multiplying by the square root of x plus 5. I want to use a different form, a different way of writing that number. And so I notice that the square root of x plus 5 is actually the same number as the square root of 2x plus 1. So I'm going to write that in instead. When you're working this out, probably the first step, you maybe don't want to write that line when you're solving your own problems. You probably want to jump straight to the step where we go, let's take both sides of this equation, put brackets around everything to the left of the equal sign and square it, put brackets around everything to the right of the equal sign and square that. And then notice that I've got a square root sign all squared, so that means I just take what's underneath the square root sign. And the same thing happens on the right.
X plus 5, not plus 1.
Oh, plus 5. Thank you. Cool. So now I've got x plus 5 is equal to 2x plus 1. And that's just a linear equation, which we've started working with, becoming more confident solving those. Once I get to a linear equation, we want to be able to solve that fairly directly. So I can subtract 5 from both sides, and I get x equals 2x plus 1 take 5. So that's going to be x equals 2x take 4. And then I can subtract x from both sides. So I'll get 0 on the left equals 2x minus x is 1x. 0 equals x plus 4. That's not quite what I want because I want x equals something. So I'm going to add 4 to both sides. So I get x minus 4 plus 4 is just x, and 0 plus 4 is 4. So I claim that x equals 4 is my solution, but we want to check it. So let's take the left-hand side, so everything to the left of the equal sign, and put in x equals 4, put in 4 instead of x. So I've got square root of 4 plus 5 is the square root of 9, which is 3. And let's see what happens if we put 4 instead of x on the term on the right-hand side. So we get 2 times 4 plus 1. 2 times 4 plus 1 is 9. Square root of 9 is 3. So the left-hand side is in fact equal to the right-hand side, so that means our solution is valid. Our solution is x equals 4. So the main tool we introduced here was taking the square root of both sides, and we practiced that. Something that may come up is, in this example, what's happening is that I've got this square root, so I'm thinking, okay, I want to square both sides. What happens if I square both sides? Remember, our process for squaring both sides is take everything to the left of the equal sign and put brackets around it and square it. Take everything to the right of the equal sign, put brackets around it and square it. On the right-hand side, I have 0 squared is just 0. But on the left-hand side, it's going to get a bit complicated. I've taken this whole term and squared it. So let's write that out. Remember, squaring says take that number and multiply it by itself. And we've got these brackets here, which means I'm taking this whole number and multiplying it by itself. So that becomes that bracket times itself. And so if I was going to solve this, let's keep working. So I want to solve this, which means we want to expand it to see if we can kind of simplify and get, we're aiming for x equals something. So if we want to expand it, that means we need to multiply it out. So multiply the first two things. 6 times 6 is 36. Multiply the outside two things. 6 times negative square root of 2x plus 4 minus 6 square root of 2x plus 4. The inside two things again gives me minus 6 times the square root of 2x plus 4. And multiplying the last two things gives me plus the square root of 2x plus 4 squared. And that's equal to 0. So if I simplify, I get 36 take 12 times the square root plus that square root gets squared here, so that becomes 2x plus 4. So in some sense, it seems like we made progress because we took this square root of 2x plus 4 and it got squared and it got cancelled out. But the problem... Is it back? All right. The problem? Maybe it's this microphone. How's that compared to before? No, not at all. How are we going? Good? Can I get some thumbs up from the back? Yeah, okay, cool. I should do that more often. All right. So we've done some squaring, some rearranging. We got this nice term to cancel out here. The problem is, though, we have this square root still. And that means we haven't really made good progress towards solving this problem. So I am going to draw a line under that and start again. So we're trying to solve 6 minus square root of 2x plus 4 equals 0. What happens if I want to do a step before I square both sides? Is there something else I can do first? Yeah, let's move the 6. I'm actually going to add this square root sign to both sides. If I add that to both sides, I have 6 minus square root of what's under there plus the square root of the same number. And so I've got a minus of that square root term and then plus that square root term. That's going to cancel out. So I'm going to get 6 equals this square root of 2x plus 4. And now I've got this square root just by itself. Let's try squaring both sides. Put brackets around everything on the left and square it. Put brackets around everything on the right and square it. 6 squared is 36. Square root sign gets squared, so that becomes what's underneath, which is 2x plus 4. And this is starting to look promising. We can subtract 4 from both sides. 36 minus 4 is 32. 2x plus 4 minus 4 is 2x. And then, so I've got 2x equals 32. So I can divide both sides by 2. 32 divided by 2 is 16. X times 2 divided by 2 again is just x. So I get x equals 16, which I need to then check. So the left-hand side of my original equation is 6 minus the square root of 2 times 16 plus 4, which is 6 minus the square root of 2 times 16 is 32, plus 4 is 36. Square root of 36 is 6, and I get 6 take 6 is 0, which is what we wanted. So our solution is x equals 16. Okay. So we've managed, looking at this example, we did want to use that process of squaring both sides down here, but we don't always want to. That's one of the tools in our toolkit for solving equations. And the other one was just to add numbers or subtract numbers from both sides. An equivalent way I could have gone would have been to take we could have subtracted 6 from both sides, and we'd end up with, on the left, let me write that out nicer. In this approach, we want to be careful of negative signs. And I'm looking at this example, this approach, because I know that when we're subtracting, when we have these negatives flying around, sometimes that can trip you up a little bit. So I've got 6 minus this number minus 6 again. So those 6 terms are going to cancel out, but that negative sign doesn't cancel out. So I'm left with negative square root of 2x plus 4 equals 0 minus 6 is negative 6. And at this point you've got 2 options. We could say, well, I don't want those negatives there. I want to just have a square root sign, and I know I can square that. So we could take both sides and multiply by negative 1, in which case I'm going to get square root of 2x plus 4 equals positive 6. But the other thing we can do is say, well, I can square both sides still. I can put brackets around everything to the left of the equal sign and square it, brackets around everything to the right of the equal sign and square it, and then negative square root of this becomes just positive 2x plus 4. And negative 6 squared becomes positive 36. So whenever I take a negative number and square it, I get a positive. And that goes back to when we multiply 2 negative numbers together, we get a positive number. So at this point, if we had those negatives there, that cancels out to give us 2x plus 4 equals 36. And then we continue solving like we did before. We'll still end up with x equals 16. Any questions about that example? Okay. I did want to circle back to a solving an equation that I know has come up in the labs already, or something similar to this. So suppose I want to solve 10x plus 5 equals 7x minus 2. I know on Monday we practiced solving linear equations, but I don't know if we solve something that has what if x is on both sides of the equation. So we're working towards x equals something. So that means that sometimes our intermediate step, our first goal is to get all of the x terms on one side of the equation. So I can, remember that I've got two numbers that are equal, so I can add the same thing to both numbers, they'll still be equal. So in this case, what if I subtract 7x from both sides? We can add 3 to both sides or subtract 100 from both sides. That's still going to give us a valid equation. So why not subtract minus 7 times x? This is just a number that we can subtract from both sides. So if our statement was true before, it's still going to be true now. I've done the same operation to both sides of this equation. And then I've got 10x and minus 7x, so that's going to give me 3x plus 5 on the left, and 7x minus 7x on the right, and I've got minus 2. So I've got 3x plus 5 equals negative 2. And then keeping in mind that we're aiming for x equals something, I don't want that constant term on the left, so I want to subtract 5. I've got a plus 5 there, so I want to subtract 5 from both sides. And then I notice I've got a plus 5 and a minus 5 on the left, so that's going to become plus 0. So I have 3x equals negative 2 minus 5 is negative 7, because they're negative numbers. And then I can divide both sides by 3, by this number here. And I get x times by 3 and then divided by 3 is just x. And on the right-hand side, I get negative 7 divided by 3, which I can't really simplify anymore. I'm just going to write that as negative 7 over 3 as a fraction. So that's a quick example that I know a couple of you, some of you have been finding difficult in the labs. Do make sure you work through Lab 1 question set. That's due on Tuesday. And just before you go, if there are any updates to how the course is running, what's happening with lectures, etc., I'll post those onto Learn. So just keep an eye on Learn in the coming days. Thanks, guys. So if I think about matching these two up, my x squared lines up with the x squared, and minus 9 matches up over here, and equals 0 matches up. So if I put x squared minus 9, that's the same as x squared plus 0x minus 9.
No, quickly take a photo of that.
Yep.
But thank you. Thank you very much.
Right, Hi.
It's the that one presentation, the presentation that we homework to do this stage.
And the cat.
That is so is the quiz. Is my English is not very good.
Oh, that's
too.
fine. Yeah, lab. Yeah, I can. I'll get you a piece of paper I can give you.
So just can see the quiz in the model. So is it the only one that we need to do?
No. So there's the lab 1 question set, which is in the week 1. In Learn, everything's in Learn.
And
Week 1. Scroll down, scroll down, scroll down, scroll down. Lab 1 question set.
in this one as well.
Yes, and those ones, 1, 2, 3.
To
Yeah.
For week 1.
Try to finish this. These ones are only due at the end of semester, but try to get them done as soon as you can because they're very useful.
Okay. So that's every week, and this one is at the end of the semester.
Yeah, but do it soon. Do it now.
Yeah.
Yeah.
Okay. Thank you.
Good. Hi.
Could I get some hardware?
Did I hear you say you're C3?
Yes.
Hillary's been trying to email you about switching to email from 1A. Can you reply to that? Follow up to her.
Going to do that.